Today we're going to start word problems, which for some is scarier than the Wicked Witch of the West. But we're going to tackle this. So today we're just going to tackle translating words into math. So we're going to do some equations and some expressions that take words and put them into math. So for addition, we might say 3 plus 4. And this is what it looks like in math. But what does it look like in words? It could look like the sum of 3 and 4. I might also say 3 is increased by 4. So sum of increased by. How else could we say 3 plus 4? I might say 4 more than 3. So 4 more than 3 would be 3 plus 4. I could also say when 4 is added to 3. So these 4 examples make you think of addition. There might be other ways that you could say to add two numbers, but these are the most common. The sum of, increased by, more than, or is added to. What about subtraction? 8 minus 6. How might I write that in words? Well, I might say 6 less than 8. Notice that it's 6 less than 8, but when I write it mathematically, it's 8 minus 6, because 6 less than 8. How else might I say subtraction in words? Well, I could say when 8 is decreased by 6. So just like addition had increased, subtraction has decreased. 8 decreased by 6. 8 minus 6. I might say the difference of 8 and 6. So the difference, or the difference between, is how far they are. And we're going to talk about that in the future. But the difference of means to subtract. I might also say when 6 is subtracted from 8. So these are all ways to say in words 8 minus 6. So how might I say multiplication? How might I show this in words? Well, I could just say 4 times 2. I might also say the product of 4 and 2. We also have some very specific words for multiplication. So I might say double, which means to multiply it by 2. I might say triple, which means to multiply it by 3. I could say half of, which means to multiply it by 1/2. Or twice, which is to multiply it by 2. So twice a number would be 2 times that number. So those are very specific multiplications. And what about division? How would I represent this in words? Well, most likely I'll just say 10 divided by 5. But I could also use the quotient of 10 and 5. So now we're going to take a look at some formulas that you're going to need to know, and then we'll do some example problems. So now we're going to talk about some formulas that you often see in word problems and that you're just going to need to know throughout the rest of this class and your time here at St. Pat. So the area of a rectangle is length times width. So area, we use a capital A, length a little l, and width a little w. So area of a rectangle is length times width. The perimeter of a rectangle, which is the length of all the sides added together, the distance all the way around, is 2 times the length plus 2 times the width. We might also talk about the distance traveled. So d for distance equals the rate at which you travel times how much time you traveled. So distance equals rate times time. We'll also spend some time talking about cost. And cost equals the number of items times the price per item. So this P, that's the price for one item, and N is the cost, or is the number of those items. And so you multiply the number of items times the price per item, and you get the total cost. Alright. One last thing before we get to some examples. You need to know that is means equals. So if I say x is 5, that means x equals 5. Okay, so let's do some examples. Okay, so my first example is 4 times a number. So I don't know what that number is, so I'm going to let that number be represented by the letter N. So 4 times a number. Well, hopefully that makes you think about multiplication. So 4 times N. How about 1/2 a number? Well, hopefully that makes you think of multiplication, and you think 1/2 times N. What about 8 more than twice a number? So now we have a couple things going on. I have 8 more than and twice a number. So that twice a number looks like 2 times N, and 8 more than is 8 plus. So you end up with 8 plus 2N. What about 7 less than a number? So I've got less than. That should make me think subtraction, but here's the tricky part. Which comes first? 7 less than a number. Well, that number minus 7. 7 less than a number. Alright, we're going to do a few more trickier. Well, not trickier, just, equations instead of statements. Alright, so if I have the sum of a number and 12 is 78, the first thing I'm going to do is underline the terms that make me think about math symbols. So sum of makes me think of addition. Is makes me think of equal. So I'm going to have a plus and an equal sign. And the sum of a number, do I know that number? No, so I'm going to let it be represented by N. And 12, so 12 will be my other number I add. And is 78, so that means equals 78. So the sum of a number and 12 is 78. Looks like N plus 12 equals 78. So what if I have 3 less than a number is 44? Well, again, I want to underline the important math terms, the terms that make me think of a math symbol. One would be less than, which makes me think of subtraction, and the other is, which makes me think of the equal sign. So I know I'm going to have subtraction, and I know I'm going to have an equal sign. It's pretty easy to figure out what goes on this side of the equal sign, and that's going to be 44. But what am I going to do over here? 3 less than a number. So that means I take this number and I want another number that's smaller by 3. So it's going to be N minus 3. It's very important that you remember that less than means you reverse the order when you write it in math. So what if I wanted to write this as an equation? The sides of a rectangle are x and x plus 4. The perimeter is 87. So there's a lot going on here, But I know that I'm talking about perimeter, and I know I'm going to have an equal sign, and I know what the lengths of the sides are. So I probably want to use the formula for perimeter. So if you take a look at your notes, you show that perimeter equals 2 times length plus 2 times width. So in this case, I'm going to have perimeter equals, well, 2 times x plus 2 times x minus 4. And I say down here that the perimeter is 87, so I'm going to say 87 equals 2x plus 2 times x minus 4. Alright, so here's one that I want you to try yourself. And it's a little tricky, so pay attention. So if a number is decreased by 5 and the result is doubled, the final result is 26. So I'm doubling what I get when a number is decreased by 5. So I want you to look at this, take a moment, underline the parts that make you think about math and math symbols. Think about what you want to do first and what it might look like. Alright, so hopefully you have decreased by, doubled, and is underlined. You might have a number, 5, result, and 26. You might have those underlined as well. That's not as big a deal. So the first thing you do is this number decreased by 5. You do that first. A number is decreased by 5. And what does that look like? Well, that looks like n, n minus 5. And then that result is doubled. So what's that going to look like? Well, that means I'm going to multiply it by 2. And then that final answer is 26.